Since the beginning of time, we have looked at the night sky and wondered about the stars we see. We've been drawing constellations, imagining stories, and lately, even studying them. And not just the position of the stars, but their entire life cycles. For example, when a specific kind of star dies, it dies in a giant explosion called a gamma ray burst. And that is something that I study. These gamma ray bursts, as the name says, are bursts of gamma radiation. So light that is way more energetic than what you're seeing right now. And these explosions are the biggest explosions we know in the universe. So really cool. But what is actually happening inside, we don't know. We can't actually see what's happening inside because the light we see mostly comes from the edge of the burst, where it spreads out. And even worse, sometimes it's blocked by gas clouds and we see even less. So how do we know what's going on inside? How can we look deeper? Well, the solution is in a tiny particle called the neutrino. Neutrinos are tiny neutral particles that only interact through the weak force and therefore travel through almost everything. Imagine there is a wall here suddenly in front of me. That would make this presentation pretty boring because I would be talking to a wall and you'd be staring at a wall. But if we had neutrino vision, we could look through this wall, see each other, and continue this presentation like nothing ever happened. But then you say, well, okay, it passes through almost everything. How do you actually detect it? The solution is pretty simple. You build a giant detector. So I work with IceCube, not the rapper, but the neutrino detector. And that consists of a cubic kilometer of ice. That's about the size of Louvain, and then you add another kilometer on top. And when a neutrino hits that ice, light is emitted, and we can see that with our cameras we put there. So here you can see the balls are cameras seeing light, and the color indicates when they see that light. So we can trace the neutrino back to where it came from, which might be a gamma ray burst. So with this method, I searched for neutrinos from the brightest gamma ray burst of all time, trying to see if we can say something about what's happening inside, what particles are there, and what are they doing. So I searched, and what did I find? Nothing. I didn't see any neutrinos. But that doesn't mean it was a failure, that I wasted my time. It actually means that we can still say something about what isn't happening inside and what can be happening instead. So we still get a view inside of the gamma ray burst. So this way, with neutrinos, we make the invisible visible. Thank you, congratulations.